There's what's known as the right-hand rule in physics, and the right-hand rule teaches us how to compute the direction or estimate the direction for a cross product between two vectors. If I have two vectors A and B, and I form a sort of shape with my right hand, I have to use my right hand to do this. I point straight ahead like a little pistol, I suppose, and move my middle finger off to the side in the direction of B. My thumb points in the direction of the cross product. So this tells me that in a situation where A points that way, B points straight down, then if I were to use my right hand, notice that my thumb is coming straight up out of the page. So C would look like if you were standing over a rocket and it was launching right at you, you would see only the tip of the rocket. We sometimes note that with a little circle and a dot in the middle. On the other hand, if this was B, and that was A, where would C point? Well, by the right-hand rule, C would point straight into the paper. So this is when we draw a circle with a little X through it, this is the opposite of seeing the tip of the vector for the rocket. This is like seeing the tail, and it's heading away from us. So this becomes a bit of a three-dimensional challenge. We have to get used to the idea of how to gauge what this direction is going to be using our right hand. Some people also use the right-hand rule in a slightly different way. If you point all your fingers out in the direction of B and then curl them toward B, like so, it forces your thumb to point in the direction of the cross product. So you start at A, curl them toward B, and you form what the direction of the cross product is. We haven't said anything about the magnitude. The right-hand rule simply tells you something about the direction, and the magnitude comes from our previous prescription.